Hello, welcome to the Argo course. My name is Mohammed and I'm very happy to be here. In the previous session, we talked about Argo-Workflow templates and we learned how to write a workflow from scratch. But in this session, we are going to use more advanced features of a workflow, such as input parameters, output parameters, artifacts, conditions, and also we're going to be familiar with some different custom resource definitions, such as WorkflowTemplate, ClusterWorkflowTemplate, and Cron Workflow. First of all, let's start with input and output parameters in a workflow. Because of that, first of all, I create a directory called workflow. And let's go to VS Code. I open the folder, workflow here, okay. I type, let's create a file called template-basic because, no, template workflow-basic. And also, I'm going to copy the content of the workflow related to the previous session and paste the content here. This is the workflow that we created in the previous session. And let's create another file called workflow-input parameters. Because I'm going to use input parameters in this workflow. Let's do that. So we have two different files. The first file related to the previous session. This is a basic workflow, and workflow input parameters, I'm going to define input parameters in this workflow. And also, let's open the dashboard UI related to workflow, DevOps.hobbies. This is the dashboard, and we have no workflows yet. Very good. I'm going to use input variables in this workflow, but how can we do that? As we learned earlier, we have multiple templates in this workflow, such as DAG. DAG template is responsible to call other templates. Task A, B, C, and D, because we have 4 other templates: container, script, resource, and delay templates. The first template here is container template. We are running a container with an Alpine image that is responsible to print a message, hello from container template. In this example, I'm going to use input parameters in this template and use that input parameter to read this message. Instead of using the message here, I'm going to use an input parameter. Because of that, when we define the name of the template, after that, I enter and I type inputs because I'm going to define 1 or more input parameters for this template. And after that, I type parameters and we can define a list of parameters here. First of all, I'm going to define the name of the parameter. So I type name. The name of the parameter will be, for example, message. And I type value because I'm going to define the value related of this parameter. For example, hello from inputs.parameters. In this example, I'm going to use and I'm going to read this message instead of this message. Therefore, I remove this message from here. And if you want to read a message from an input parameter, you have to use this syntax. First of all, let's use double curly bracket like this. And I type inputs dot parameters dot the name of the parameter. The name of the parameter is message. So I type message. So this container will create a log, will create a message with this content. Hello from inputs.parameters. So if you want to read this input parameter, if you want to read the value related of this parameter, you have to use this syntax. Inputs, parameters, and the name of the parameter. The name of the parameter here is message. I save the file and let's go to submit this workflow. I type argo submit workflow input parameter -n argo. Very good. Let's go to workflow dashboard and the tasks are running. The first task, task A, is running. Task A related to container template. So I'm waiting for the log. Let's click on A and click on logs. And as you can see here, this is the message that we defined earlier. Hello from inputs.parameters. It means that we are trying to read this message from an input parameter. Very good. It was about input parameter. We can define input parameters with several ways, and we can read the value from different approaches. The first approach is here. When we define the name, we can define the value. If I comment out this value from here and I save, when I go to submit this workflow, I receive an error that inputs.parameters.message was not supplied. It means that this parameter has no values because I comment out this value. The second approach is this. When you are trying to call this template, task A, and the template is container template. So I'm trying to call this template. When you are trying to call this template, you can define the value here instead of here. For example, instead of inputs, I have to type arguments. Parameters. The name of the parameter is this, message. So I copy the name of the parameter here. Very good. And the value is, for example, hello from tasks.taska dot arguments dot parameters dot message. I mean that I'm reading the value from tasks.taska dot arguments dot parameters dot message. So I'm defining the value when I'm calling the template. So I comment out the value from here and I define the value here. Let's save the file and submit the workflow again. This is the second workflow and I'm waiting for the logs of task A. Let's click on it, logs. And yes, hello from task A arguments parameters at message. So I defined a value when I called the template. So it was the second approach. And also, we can define parameters as a global parameter. We can define global variables, we can define global parameters for our workflow. Because of that, after spec block, here I type arguments, parameters. The name of the parameter is message, and the value is hello from spec dot arguments dot parameters dot message. So I defined a global variable. After spec block, I define an argument called message. So I define a global parameter. I want to read this value instead of this value. Because of that, I remove this message, and let's use this syntax. Double curly bracket. Instead of inputs, I type workflow, because this parameter is a global parameter. Because of that, I use workflow instead of inputs. Workflow dot parameters dot message. I'm reading the value from the workflow because this parameter is a global parameter, because I defined this parameter under spec block. So this is a global parameter. Workflow.parameters.message. And here I type inputs.parameters.message. And the value here is commented out. Let's save the file and submit this workflow again. As you can see here, we have a parameter here. Parameters, message, and the message is hello from spec.arguments.parameters.message. This parameter has been appeared here because this is a global parameter. Let's go to Argo-Workflow dashboard. This is the third workflow. Let's click on A and click on logs. And yes, hello from spec.arguments.parameters.message. So we define a global variable. Very good. And the last approach, what is the last approach? You can also comment out the value from a global parameter. We have no values here. The value here is commented out. We have no values here, and also the value here is commented out. In this time, I'm going to read the value from terminal when we are submitting the workflow. First of all, let's save the file. And when I submit this workflow, I receive an error. Spec.arguments.message.value is required because I commented out the value here. So I need to define a value for message parameter. In this time, I'm going to define this value when I'm submitting the workflow. Because of that, when I type argo submit workflow input parameters.yaml, I type dash P, it means that I'm defining a parameter. The message equals hello from terminal. Dash P, the name of the parameter, and the value of the parameter is hello from terminal. As you can see here, the message is this, hello from terminal. Let's go to Argo-Workflows, and this is the fourth workflow, and let's click on logs here. And yes, hello from terminal, because we define the value related message when we submitted the workflow with dash P switch. Okay, it was about input parameters, and we tried to define this parameter with several approaches. Very good. In this time, I'm going to use output parameters. But what does it mean? Let's imagine that we have a template, that this template will produce a random number, for example, 20. And I'm going to use this random number, this output, as the input of another template. Let's go to the example here. For example, we have a template called ScriptTemplate, and this template will produce a random number. And I'm going to use that random number here in ResourceTemplate. Let's do that. First of all, I'm going to create a new file called Workflow output parameters. And let's copy the content from the basic template here. And okay, very good. The task A will be run first, and then B, and then C, and then D. Okay. I'm going to define an output parameter for a script template. So instead of inputs, I type outputs. Outputs parameters. The name will be, for example, random random number output. And its value will be, for example, 20. So I defined an output parameter for a script template, and its value is 20. I'm going to use this output as the input of another template called ResourceTemplate. So I need to define an input parameter for ResourceTemplate. So I type inputs parameters. The parameter is random in, random number input, and it has no values here right now. As you can see here, ResourceTemplate is responsible to create a config map, and this config map has a data called created by Argo-Workflows. I'm going to add a new data for this config map. For example, random number. And its value will be inputs dot parameters dot random in. As you can see here, inputs, parameters, random in. But random in has no values. The value of this parameter will be the output of random out, and its value is 20. I'm going to use this value here. So a script template is task B, and resource template is task C. I'm going to use the output of task B as the input of task C. So in task C, I type arguments, parameters. The name of the parameter here is random n. I'm defining a value for random n and its value. What is the value of random n? As I said earlier, I'm going to use the output of task B as the input of task C. So I type tasks, task B, outputs dot parameters dot random out. Task B has an output. Task B has an output, and its output is random out, and the value of random out is 20. So the input here, random in, and its value is 20. Task B, a script template, has an output parameter, and the name of its output parameter is random out, and its value is 20. So we will have a config map with two different data created by Argo-Workflows and a random number. And the value of random number must be 20. So I save the file, and let's go to submit this file, this workflow, argo submit -n argo workflow output parameters. Okay, let's go to Argo-Workflows dashboard. I'm waiting for task C because it will create a new config map with two different data. If I click on task B, and if I click on inputs and outputs, as you can see, we have an output parameter for task B, and its value is 20. So I type kubectl get config map -n argo, and this is a new config map because I copy the name of the config map. I type kubectl get config map here -n argo and -o. Yeah. As you can see here, this is a config map with two different data created by Argo-Workflows, and the random number is 20. Very good. So I used the output of a template as the input of another template. But we have a problem here. This number is a static number, and I don't need to use this. As you can see here, in a script template, we are using Python, and we are using a module called random, and it will produce a random number between 1 and 100, and it will print its random number. I'm going to produce this random number and write that random number into a file. Because of that, I remove print I from here, and I type with open tmp random.txt, and the mode is write as f. f dot write I. It means that the random module will produce a random number between 1 and 100, and I is a random number. So I'm going to create a new file called tmp_random.txt that will contain the random number. And instead of value, I type value from. And here I type path. The path is tmp_rand.txt. It will read the content of tmp_random.txt as an output parameter. I save the file, and let's submit this workflow again. This is the new workflow. Instead of a static number, I'm going to produce a random number with a random module and create a new file with its content. Failed because argument must be a string, not integer. Very good. So I need here to convert integer to a string. So I type stri. It will convert integer to string. Let's submit the workflow again. The config map will not accept an integer. It will accept a string. So I converted it to a string. Task B. Let's click on it. As you can see here, its output is 54 because we have a file called random.txt and its content is 54. Let's go to terminal. I type kubectl get config map -n argo. This is a new config map. kubectl get config map -n argo. This and -o. Yeah. Yes, the random number is 54, and the output of task B is 54 too. Okay, it was about output parameters in Argo-Workflows. So we can use a value with a static value, or we can read a value from a file like this, tmp_random.txt, because we used this syntax to create a file with the content, and this content is a random number. Very good. The next thing that I'm going to talk about is WorkflowTemplate. WorkflowTemplate is a CRD, a custom resource definition. If you are familiar with programming languages, you should know functions, and we use functions to prevent any duplications in the code. We create a template and reuse it multiple times in the code. I want to do the same using WorkflowTemplate. I'm going to create a workflow template once and reuse it multiple times in the different workflows. Because of that, let's create a new file here called WorkflowTemplate.yaml. Let's copy the content from Workflow Basic to Workflow Template. Very good. First of all, I'm going to change its kind from workflow to workflow template, like this. And instead of generate name, I want to use name. and its name will be Argo-WorkflowTemplate. Very good. This is just a template, so I don't need to use entry point. I delete it. And also, in this example, I'm going to use a single template. For example, container template. So I remove all other templates from here. Container template. So I remove all other templates from this definition. So we have a file. Its CRD and its kind is WorkflowTemplate. Its name is Argo-WorkflowTemplate, and we are using a single template here. Let's imagine that this template will be used multiple times in different workflows. So I define it here. Its name is container template. We are running a container with Alpine image that is responsible to print this message. Very good. I save the file. Let's go to Workflow Basic. I'm using container template in WorkflowTemplate, so I comment out or remove the block related to container template like this. Okay. As you can see here, I'm calling a template called container template, but I commented out this template here. Instead of template, I write template ref because I'm going to refer to a workflow template. So I type template ref. Its name, the name of the workflow template. The name of the workflow template is Argo-WorkflowTemplate, like this. And the template that I'm going to use in this workflow template is container template. Let's imagine that this workflow template may have multiple templates. I'm going to refer to a specific template. So I copy the name of the template here from here and paste it here. The name of the template is container template. Very good. Let's go to the terminal. First of all, I'm going to create our workflow template. We have a file here called WorkflowTemplate.yam. So I type argo template create workflow template -n argo. If I type argo template list -n argo, we have a template called Argo-WorkflowTemplate. So if you want to create a workflow template, you have to use this command, argo-template create, the name of the file, and the namespace. Okay. So now I can type argo submit -n argo workflow basic. Very good. Let's go to Argo City to Argo Workflows dashboard, and we have a workflow running here. The task A has been defined in our workflow template. I'm waiting for that, pod initializing. As you can see here, I'm going to refer to a workflow template called Argo-WorkflowTemplate, and the name of the template that I'm going to use it, container template. Very good. Task A, its phase is succeeded. Very good. And everything is good. If I click on A and its logs, I see the message, hello from container template. So everything is good. In this time, I'm going to use input parameters in this template. So let's create an input parameter for this template. So I type inputs parameters. The name of the parameter is message and the value is hello from WorkflowTemplate inputs.parameters. Very good. First of all, I need to delete the previous template. So I type Argo-Template delete this template. The template has been deleted. And let's create it again. But in this time, I'm using input variables and input parameters in my workflow template. Oh, I forgot it. I need to use this syntax here. Inputs dot parameters dot message. Very good. Let's create it. Okay, and let's submit the new workflow. Let's go to Argo Workflow dashboard, and this is my new workflow. I'm waiting for the logs of this container. Pod initializing. I'm waiting for that. Okay, let's click on logs. And yes, hello from WorkflowTemplate inputs.parameters. Okay, as you can see here, I defined the value inside WorkflowTemplate, but it's not very good. I'm going to define the value in my workflow instead of WorkflowTemplate. So I comment out this line related to value from WorkflowTemplate, and I'm going to define the value inside workflow when I'm calling this WorkflowTemplate. So I need to type arguments, parameters. The name is message, and the value is, for example, hello from workflow. Okay, so I'm using and I'm defining the value inside workflow. The value is commented out in WorkflowTemplate, but I'm using inputs.parameters.message in WorkflowTemplate, but the value is inside workflow when I'm calling and I'm going to refer to our WorkflowTemplate. Very good. Let's delete the previous template and create the new ones. Very good. And submit the workflow again. But in this time, the value has been defined inside the workflow. I see the logs here, and you can see that hello from workflow. Very good. And also, the next way is this. If I remove the arguments from here, in this time, as we learned earlier, we can define a global parameter in my workflow. So if you want to define a global parameter inside your workflow, you have to define it under a spec block. So under a spec block, I type arguments, parameters. The name of the parameter is message, and the value is, for example, hello from spec dot arguments dot parameters. It means that I defined this value under spec block as a global parameter. And also, I removed the inputs parameters from my workflow template completely. And instead of inputs, I type workflow. The variable related to message will be defined in the workflow as a global variable, and I can use it in my workflow template with this syntax: workflow, that parameters, that message. And I don't need to define any inputs here, because this variable will be used from workflow as a global parameter. I save both of these files. Let's delete the previous template and create the new one and submit the workflow again. Yes, the message is hello from expected arguments.parameters. Let's go to Argo-Workflows dashboard and see the logs of the new container here. I'm waiting for the logs of this container to see what is the message. I click on A and click on logs. And yes, hello from spec.arguments.parameters. Very, very good. So, we learned how to create a workflow template like this, and we learned how to refer to a workflow template like this. And also we learned how to define an input parameter or a workflow parameter and use it in our workflow template. Okay. The next CRD, the next custom resource definition, is ClusterWorkflowTemplate. If you want to limit the workflow template to a specific namespace, you have to use WorkflowTemplate. But if you want to use the workflow template in all the namespaces, you have to use a separate CRD called ClusterWorkflowTemplate. And if the workflow template is a cluster scoped, when you are going to refer to its template, you have to use this syntax like this. Cluster scope equals true. It means that this template is a cluster template, cluster workflow template. So if you want to limit the workflow template to a specific namespace, its kind is workflow template. But if you want to use this template, this workflow template, in multiple namespaces, you have to use cluster workflow template. And then if you are going to refer to that template, you have to add this line, cluster scope equals true. Very good. It was about workflow template and how to refer to a template, how to use input parameters, global parameters, and about cluster workflow template. Very good. The next thing that I'm going to talk about is Cron Workflow. Cron Workflow is a CRD, a custom resource definition. Let's imagine that I'm going to run the workflow every minute, every 2 minutes, every 1 hour. In this situation, I use Cron Workflow based on a specific scheduling. Let's go to the directory related to the current session, Argo-Workflows, CRDs, and artifacts. And let's go to custom resource kinds. We'll learn how to use ClusterWorkflowTemplate, WorkflowTemplate, and in this time, I'm going to use Cron Workflow. Let's copy the content related to Cron Workflow and go to VS Code. I type cronworkflow.yaml. Very good. As you can see here, the kind is Cron Workflow. And also, we have additional parameters, we have additional options in this type of workflow, Cron Workflow. The first parameter and the first option is schedule. But what is that? Schedule at which the workflow will be run. For example, I'm going to run this workflow every 2 minutes. So I use this syntax. I'm going to run this workflow every minute. So I use this syntax. So I define the scheduling of this workflow. The next parameter is suspend. The suspend is false by default. But if true, workflow scheduling will not occur. But if false, that is a default value, the cron workflow will be run based on schedule. The next parameter in the next option is concurrency policy. Policy that determines what to do if multiple workflows are scheduled at the same time. For example, I define this cron workflow to be run every 2 minutes. But I submit this workflow manually, so a workflow is running, and after, for example, 10 seconds, another workflow will be run based on schedule time. So we will have 2 workflows running at the same time in this situation. So this policy determines what to do. If the policy is allow, it means that both of these running workflows will be run without any problem. They will run without any problem because the policy is allow. But if the policy is replaced, it means that the previous workflow will be terminated and the new one will be replaced because the policy is replaced. And if the policy is forbid, the previous workflow is running without any problem, but the new workflow won't be run because the previous workflow is running yet. Because of that, the policy is forbid. And the new workflow won't be run. The next option is starting deadline seconds. By default is 0. But what is that? Number of seconds after the last successful run during which a missed workflow will be run. And also we have two options, successful job history limit and failed job history limit. Successful is number of successful workflows that will be persisted at a time. The default is 3 for successful job history limit. And failed is number of failed workflows that will be persisted at a time. The default number for failed job history limit is 1, but I'm using 2 here. And the default number for successful is 3, but I'm using 2. Okay. And the rest of the workflow is the same that we learned in this course. First of all, I'm going to use allow policy. It means that if multiple workflows are running at the same time, there is no problem. They will run without any problem. Because of that, first of all, I'm going to use allow problem. Successful job history limit is 2 and fail is 2. Suspend is false, so the Cron workflow will run without any problem. And the schedule will occur. And this workflow will be run every minute because I'm using this syntax. Let's save the file. Let's go to terminal. We have a new file here called Cron Workflow. If you want to use a Cron Workflow, you have to type argo cron create Cron Workflow-n argo. So if I type argo cron release-n argo, we have a Cron workflow here that will run every minute. Let's go to dashboard. In the left, we have an option here called Cron Workflows. I click on it. As you can see here, the workflow will be run in 20 seconds. So I'm waiting for that. There is no workflow running here right now, but the new workflow will be run in 5 seconds. As you can see here, Argo Cron Workflow is running based on schedule. And the next workflow will be run in 1 minute because this Cron workflow will be run every minute, as you can see here. So this is the workflow is running, and the next workflow will run in 30 seconds. If I click on this workflow, for example, and if I click on submit, I submitted this workflow manually. So we have one for workflow is running. This is the workflow that I submitted manually. Another workflow will be run in 5 seconds. I'm waiting for that. And as you can see here, we have two workflows running at the same time, and they are running without any problem because concurrency policy is allow. This workflow is running without any problem, and also this workflow finished without any problem because concurrency policy was allow. If you want to delete a workflow, a cron workflow, you have to type argo cron delete -n argo, and I type the name of the argo workflows. Very good. And if I type list, we have no cron workflows. Yes, no cron workflows yet. In this time, I'm going to change the concurrency policy to replace. It means that if two workflows are running at the same time, the previous workflow will be terminated and the new one will be run without any problem. Let's do that. Let's create the Cron workflow again. Very good. I refresh the page. Okay. It will be run in 20 seconds. I submit this workflow manually, so there is a workflow running. This workflow is running because I submitted it manually, and the new workflow will be run in 5 seconds. Let's see what will happen. Yes, as you can see here, the previous workflow finished with a failure. Why? If I click on it, you can see that the phase is failed. And the message is this: stopped with strategy terminate. It means that two workflows were running. Because of that, the policy was replaced. Therefore, the previous workflow terminated and the new one replaced. So the new workflow finished successfully without any problem. It was about replace strategy. Let's delete the previous Cron workflow from here. Very good. In this time, I'm going to use forbid. It means that if a workflow is running, the new workflow won't be run. Let's create it. Very good. This workflow is the first workflow. I'm waiting for that to be run. And as you can see here, the policy is forbid. Okay, the new workflow is running. And the next workflow will be run in 40 seconds. In this time, I'm going to submit this Cron workflow manually. So I click on submit. As you can see, this workflow is running because I submitted it manually. And the next workflow will be run in 10 seconds, but the concurrency is forbid. So let's see what will happen here. Okay, as you can see here, we have one workflow running. This is the previous workflow that is running yet. And the new workflow didn't run because the concurrency policy is forbid. Very good. So it was about Cron Workflows, and as you can see, we have two different Argo Cron Workflows because successful jobs history limit is 2. We won't see 3 or more Argo Cron Workflows here because the successful job history limit is 2. So if I click on this workflow, you can see that successful job history limit is 2. This workflow is running. If this workflow has been finished successfully, I'm waiting for the finishing of this workflow, the previous workflow will be deleted and we will have 2 workflows, 2 Argo Cron workflows, because job history limit, successful job history limit is 2. I'm waiting for the finishing of this workflow. Now we have 3 Argo Cron workflows. Yes, the previous Argo Cron workflows deleted because successful job history limit is 2. So now we have 2 different Argo Cron workflows. Very good. It was about Argo Cron workflows. And also, if you want to delete the Cron workflows using dashboard, you can click on Cron Workflows and click on delete and delete the Cron Workflows. You can delete this workflow using terminal or using dashboard. There is no problem. Very good. I'm going to talk about artifacts in Argo Workflows. Let's imagine that we have 2 different templates in the workflow, template A and template B. Template A is responsible to generate an artifact, to generate a random number, for example, to generate a random number, and puts that random number into a file, into an artifact. So in this template, we will have a file or an artifact that its content is a random number. And also I have another template called template B that is responsible to get that file, to get that artifact, and see the content of that file, see that random number. So this is one of the use cases of artifacts in the workflow. Generating an artifact in a template and using that artifact in another template. The second use case of artifacts is, for example, I'm going to install Docker Compose in kubectl utilities in my container. So I need to use artifacts in this situation. I need to get the binary files of these 2 utilities to install them in my container. So I need to use artifacts. In this scenario, I'm going to do 2 different tasks. The first task will be like this. I'm going to generate an artifact in a template and using that artifact in another template. For example, I'm going to generate a random number and read that random number in another template. The second task is installing and getting the binary files of Docker Compose and kubectl utilities and install them in a container using artifacts. Okay, let's go to VS Code to complete and to do the first task, generating a random number and generating an artifact and using that artifact in another template. So I type workflow-artifacts.yaml. This is a new file, and I copy from workflow basic to workflow artifacts. Very good. First of all, let's remove arguments and parameters from this workflow. I don't need to use them right now. And also, in this example, I'm going to generate a random number into this template, a script template. A script template is responsible to generate a random number and puts that random number into a file. So in a script template, this is my script template. I'm using random module to generate a random number between 1 and 100. And I'm going to put this random number into a file. So I type with open, for example, tmp random.txt, and the mode is W as F. I type f.write I. So I'm using this syntax in Python to create a file called random.txt with W mode to write into that file. And I'm writing the random number into random.txt. Very good. And also, I need a new template. I need a new template to read the content of this file and see that what is the random number. So I need to create a new template to do that. Because of that, I copy from here and paste it here. I type D, a script template -new. Very good. And this is task E. Very good. So we have a new template called a script template new. I copy from here and paste it here. I changed the name from a script template to a script template new. In this example, I'm going to do something. For example, I'm going to read the content of this file to see what is the random number. But before that, let's go to a script template from here. I need to use output for this template. So I type outputs, and instead of parameters, I type artifacts. The name of the artifacts, for example, is rand num out, and instead of value, I type path. The path is this, tmp random.txt. This script is responsible to generate a random number and puts that random number into tmp random.txt. So the output of this template is tmp random.txt. This is the output of a script template. I need to use inputs instead of outputs for a script template new, because this is a new template that is responsible to see the content of that file. So instead of outputs, I need to use inputs in this template. And instead of parameters, I type artifacts. The name of the artifact is, for example, rand nom in, and the path. The path can be different from here. The path in a script template is tmp randnom.txt because this is the generated file from this template. But the path here in a script template new can be different. For example, I can type tmp nom.txt. So these two paths can be different. There's no problem. Very good. So this is my input, tmp nom.txt. I need to read the content of this file. Because of that, I type with open tmp nom.txt. Here the mode is R by default, and I type number equals f dot read, and I type print number. I'm using tmp nom.txt. This is task D, a script template new. When I'm calling this script template new, when I'm calling this template, I need to pass it its input. So I type arguments, artifacts, the name of the artifact is random in, very good, and instead of value I type from. Tasks dot script template is task B, so I type that B. Outputs dot artifacts dot, the name of the artifact in script template is random out. So I type this random out. This is the output of a script template. Task B, outputs, artifacts, and random out. And instead of value, I type from for artifacts. Very good. So, one more again. We have a template called a script template that is responsible to generate a random number and puts that random number into tmp random.txt. So the output of this template, is random.txt. And also, I'm going to read the content of this artifact into another template. So we have a template called the script template new, and we have an input into this artifact called tmp nom.txt. And I'm going to read the content of that file here. So I type number equals f.read and print number. And when I'm calling task D is a script template new here, I'm passing an artifact here, random in equals task B outputs artifacts random out. This is the output of a script template. I save the file and let's go to the terminal. I type argo submit argo workflow artifacts -n argo. I received an error. What is the error? Argo workflow template container template not found. Container template. Container template is commented out. Oh, in the previous example, we used template ref. We used workflow templates. I don't need to use it again. So I remove here, and the name of the template is container template. And also I need to uncomment these lines. Very good. And the random number is integer, and I need to convert it to a string. So I type stri. Very good. I think everything is good. Let's submit it again. And okay, let's go to Argo-Workflows dashboard. I'm waiting for the final result of Argo-Workflows. To see what's happening. Template B is running. Template B is a script template. It's responsible to generate an artifact for us. Oh, we received an error. If I click on task B, we have an error. We have an important error here. If you pay attention on message, it says that you need to configure artifact storage. More information on how to do this can be found in this doc. Let's go to this link. The title is Configure Your Artifact Repository. This line is so important. To run Argo workflows that use artifacts, you must configure and use an artifact repository. As you can see here in this example, I'm using artifacts, so I need to configure an artifact repository. Argo supports NES3 compatible artifact repositories such as AWS, GCS, and MinIO. I'm going to use MinIO as our artifact repository in this scenario. Okay, because of that, I type MinIO Helm chart. If you want to install the Helm repository related to MinIO, you can use this command, helm repo add MinIO, and this is the Helm repository of MinIO. But the Helm repository related to MinIO exists in my local machine. So if I type Helm repo list, the MinIO exists in my local machine, MinIO Helm repository. So I don't need to add it. Let's install MinIO in my local machine. So I type Helm install. The name will be, for example, argo-artifacts MinIO/MinIO. I need to access to MinIO dashboard, so I need to change the service type of MinIO to node port. So I type --set. Service.type is node port, and also --set service.node port is this --set full name override equals argo-artifacts and argo namespace. Very good. If I type kubectl get pod -n argo, We have lots of pods here. These are the pods, these are the containers related to the workflows that we used in these examples. But one of these pods is Argo artifacts. This is the pod related to MinIO. And also, if I type kubectl get SVC, we have a node port service. This is the service related to MinIO. And this is the node port of MinIO. So I type HTTP localhost. This is the node port, and this is the dashboard related to MinIO. If you want to access the MinIO dashboard, you have to use access key and secret key. But where can I find them? If I type kubectl get secret, we have a secret here called argo-artifacts. kubectl get secrets argo-artifacts and argo-o. Yeah, as you can see here, we have two data for Argo artifacts. This is the base64 of the access key of MinIO, and this is the secret key of MinIO. If you want to access to them, you need to type kubectl echo backtick kubectl get secret argo artifacts -n argo-o JSON path dot data dot access key and pipe it to base64 decode. This is the access key related to MinIO, and also the secret key is this. Very good. I copy the access key and paste it here. And I copy the secret key and paste it here. Very good. This is the dashboard related to MinIO. The first step to integrate MinIO with Argo Workflows is creating a bucket into MinIO. If I click on plus and click on create bucket, I need to create a bucket, for example, my bucket. I need to store the artifacts into this bucket. And also, I need to create a secret, to create a generic secret to store the base64 decoded of access key and secret key of MinIO. So, I need to use this command kubectl create secret, for example, my -MinIO cred kubectl create secret generic -n argo. The name of the secret is my MinIO cred, and also -- from -literal access key. The access key is this, and also -- from literal secret key. The access key is this. And the secret key is this. Very good. So if I type kubectl get secret kubectl get secret -n argo. We have a new secret called my MinIO cred with 2 data, access key, and also secret key. The base 64 decoded of access key and secret key of MinIO. Very good. In the last step, what is the last step? If I type kubectl get config map -n argo, we have an important config map in this namespace called workflow controller. This is the config map related to the controller of workflows. This is so important. But as you can see here, it has no data in it. Okay? If you want to integrate MinIO with workflows, the first way is adding a data into workflow controller, and this is a data related to MinIO. So I type kubectl edit config map, this config map related to workflow controller -n argo. As you can see, we have no data block. I already created a file here called s3.txt. I copy this block, paste it here. This is my data block. The name is artifact repository, archive logs equals true. My bucket, this is the bucket that we created earlier. As you can see here, we created a bucket called my-bucket. So I'm going to use this bucket. Endpoint, this is the service name of MinIO. This is the service name, Argo artifacts. And default, this is the service namespace. I'm using Argo namespace, so I change it to Argo and secure true. As you can see, this is the secret that we created earlier. My MinIO cred. I created a secret called my MinIO cred. It has 2 different datas, access key and secret key, as you can see here. The name of the secret is my MinIO cred, and the name of the data, the key is access key, and the key is secret key. Very good. So these are the lines related to integrating MinIO with Argo workflows. I saved a file, very good. And now let's submit the workflow again to see what will happen. The workflow is running. I'm waiting for the final result of this workflow. Task B is generating an artifact, and here is empty, as you can see here in MinIO, my bucket. Yes, Task B generated an artifact called random-out.rgz. Random-out. If I go to the workflow, this is my script template. Okay? And as you can see, its output is random-out. So its name is random-out. And this is a tar.gz file. Let's download it. If I go to this, we have a file here called random.txt. The name was random-out, and the file is random.txt. So I click on it. This is the random number. The random number is 84. Very good. So task B generated an artifact. And also task D was responsible to read the content of task B. Let's go to task D and see the logs. In the logs of task D, we will see this number, 84. logs. And yes, this is the number. This is the random number that generated in task B. Very good. Everything is good. And if I go to MinIO dashboard and if I refresh this page, we have a new entry. This is the name of the workflows this is the name of the workflow that we saw it here. Argo-Workflow SLTV2. SLTV2. Well, these are container template, script template, random, targz, and this is the log. And everything is good. You can download it here, download object. And very good. And you can download it from MinIO too. Very good. This is the first way. So I added the data block into workflow controller. This is the first way. The second way is creating a separate config map. I don't need to add a data block for the workflow controller. I can create a separate config map to add the data block into that. Okay? So let's go to the Git repository of this course and artifacts directory. We have a config map here called MinIO artifact repo-cm.yam. I copy the content. First of all, I deleted the data block from workflow controller. Very good. So if I submit the workflow again, we will receive an error because I deleted the data block into workflow controller. So we will receive an error in this workflow. I'm waiting for the error. And also I'm going to create a file here called MinIO config map.yam, and I paste the content here. Very good. Yes, we will receive an error because I deleted the data block into workflow controller. The second way is adding a separate config map instead of workflow controller. We created a separate config map and add the data block into that. The name of the config map is artifact repository. The name is so important. Please pay attention to this comment. If you want to use this config map by default, name it to artifact-repositories. This is the name artifact-repositories. If you want to use this config map by default, name it artifact repositories. Otherwise, you can provide a reference to a different config map. The name of the config map is artifact-repositories. This is the name that Argo-Workflows uses by default. So I don't need to do anything else. And we have also an annotation here. And the default artifact repository. This is the name of default artifact repository. The name of the artifact repository is MinIO artifact repo, and this is MinIO artifact repo. If you have multiple artifact repository here, you can set a default. For example, I have a single artifact repository, and its name is MinIO artifact repo. But if you have multiple repos, you can set a default in this annotation. The bucket is my bucket. This is the name of the service related to MinIO. This is the namespace. And this is the secret that we created, access key and secret key. Everything is very good. So please pay attention to this name. The name is artifact repositories. This is the name that workflows are used by default. So I don't need to do anything else. Very good. I save the file and let's I type kubectl apply -f MinIO config map -n argo. kubectl get config map -n argo. We have a new config map here called artifact repositories. Let's submit the workflow again to see what's happening. We added a config map. We added a separate config map instead of workflow controller. This is the second way. I'm waiting for task B to generate an artifact to see it here. I'm waiting, yes. Task B generated an artifact. It means that I configured artifact repository very well. Very good. So if I refresh this page, this is the second workflows here, and very good. Okay, everything is good. As I said earlier, here, I said if you want to use this config map by default, name it artifact repositories. It means that if the name of the config map is artifact repositories, I need to apply it in Argo namespace and I don't need to do anything else. But if I change its name, first of all, let's delete the previous config map from here. Very good. kubectl get config map, yes. In this time, instead of artifact repositories, I'm going to use artifact repository. I changed the name and let's apply it again. In this time, if I type kubectl get config map and this is the new config map, let's go to see its content. As you can see here, the name of the config map is artifact-repository instead of repositories. And let's submit the workflow again to see what's happening. This is the new workflow. In this time, we will receive an error. We applied a config map, but I changed the name from artifact repositories. This is the name by default. I changed the name from artifact repositories to artifact repository or anything else, doesn't matter. I changed the name of the default. Yes, we received an error because there's a problem. If you change the name of the config map from artifact repositories to something else, like artifact repository or anything else, it doesn't matter, you have to provide a reference to a different config map. Let's go to GitHub and let's go to workflow. These are two lines. I need to use them. I changed the name of the config map. Because of that, I need to create a reference to this config map. I need to create a reference. Under spec block, I have to add these two lines. Artifact repository ref, the name of the config map, artifact repository. Why? Because I changed the name of the config map from artifact repositories to artifact repository or something else. If I change the name, I need to create a reference to that config map in my workflow under spec block. I save the file and let's submit this workflow again. Let's go to workflows dashboard, and this is the new workflow. And this time we won't see any error because we are using a reference to a new config map with a new name. But if the name of the config map is artifact repositories, you don't need to create a reference to your config map. Yes, the artifact generated without any problem. And if I refresh this page, this is the third workflow. Very good, everything is good. It was about MinIO, it was about artifact repository and integrating MinIO with Argo-Workflows to generate artifacts and store artifacts in the fact. The second task is getting the binary files of Docker Compose and kubectl utilities to install them in my container. This is the second task. This is the second use case of artifacts. Because of that, we have a file here called hardwired artifacts. And if you see the file from here, I type it here. The new file, hardwired hardwired.yam. Good. As you can see here, I'm using artifacts, and instead of outputs, I need to use inputs because I'm using inputs artifacts to get the artifacts. For example, I'm getting this repository. This is the repository related to this course, and this is the branch that I'm going to use it. Check out the main branch of the Argo repo and place it at @DevOps hobbies. Revision can be anything. Can be a branch name, can be a tag, can be a commit ID. It doesn't matter. But check out the main branch of the Argo repo and place it at DevOps hobbies path. And also, the second example is this. It uses this URL, the URL related to Docker Compose, and place it at user local bin Docker Compose. Very good. Let's save the file. And I type argo submit hardwire-n argo. And at the end, it runs a container with Alpine image to ls these two paths, DevOps hobbies and user local bin Docker Compose, to see their artifacts. The binary file related to Docker Compose and the files related to Argo CD tutorial repository. This is the workflow related to hardwired artifact. And I'm using artifacts, but in this time, I'm going to get the binary file of Docker Compose. I'm going to check out my repository and place it at a specific path. This is the second use case of Argo-Workflows. In the first use case, we generate an artifact using output and getting the artifact using input. As we did in the first example, we generated a random number, we generated an artifact, and we used that artifact to see the content of that file using input artifact. And in this example, I'm using input artifact to get something. For example, to get the main branch of a Git repository, to get the binary file of Docker Compose, of kubectl, or anything else. I paused the video to wait for the final result of this workflow. Okay, it has completed and the phase is succeeded if I click on logs. As you can see here in the last step, I used a template, container template, to ls these two paths. In DevOps hobbies path, I have to see the files related to this repository in this branch. And also in this path, I have to see the binary file related to Docker Compose. So I click on logs. Yes. This is the file related to Docker Compose, user local bean, Docker Compose, and DevOps hobbies. These are the files related to Argo City Git repository in main branch. Very good. It was about artifacts, and we used several ways to see how artifact works. Very good. If I go to GitHub repository in artifacts directory, let's zoom in. We have two other files, conditional artifacts and conditional parameters. Let's click on it, conditional parameters. I'm using DAG template in this example. It's responsible to call 3 different templates: flip coin template, heads template, and tails template. I have defined when condition for heads template and tails template. It says that if tasks dot flip coin template, this is flip coin template. If tasks dot flip coin dot outputs dot result equals heads, call or run heads template. And if the result of the output of the flipcoin template is tails, run or call tails template. Because of that, I'm using when conditions for heads and tails templates. And also, we have another file called conditional artifacts. In this example, I'm using steps instead of DAGs to call the templates. And instead of DAGs, I have used steps here in the syntax. Steps dot flipcoin dot output dot result equals heads. If this is true, run heads template. Or if this is true, run tails template. You can follow these 2 different files to see how when conditional templates work. Very good. It was about artifacts. In this session, we talked about input parameters, output parameters. We talked about WorkflowTemplates, Cron Workflows, ClusterWorkflowTemplates, and also we talked about artifacts, artifact repositories such as MinIO, and integrating MinIO between MinIO and Argo-Workflows. And also we talked about conditional parameters and conditional artifacts, conditional workflows, And very good. That's enough for this session, and see you soon.